Hello, everyone. Welcome to PASS Virtual Summit 2020 and my session on Move Your Entire BI Platform to Azure and Power BI. I'm Steve Wake, and I will be presenting this session for the next couple of hours. The plan is to have an hour of the session and then do a 15-minute break, have another hour of the session, and then actually I will be available live for Q&A for the last 15 minutes of the session. So what you're seeing right now has actually been pre-recorded, but I will be in the chat available to take questions during this time. So feel free to post any kind of questions you might have during the presentation into that chat window, and I should be there to monitor those and answer any questions. And like I said, anything that I see as a recurring question, I may hold off on answering it in the chat and answer it live via video after the session is done in those last 15 minutes. So feel free to continue to chat with me throughout this time. So once again, thank you for coming to the PASS Summit, this year being virtual, of course. But for those of you who don't know or have not been previously members of PASS, which you all are now, if you signed up for the summit or have been to any of the other SQL Saturdays, local groups, or any of these other events that PASS puts on regularly, you are already a member for these. So take advantage of everything that PASS has to offer. Most things are free. They have now rolled out the Pro membership that does have a yearly fee. But there are still plenty of things available out there that are all free as well. So feel free to check that out at pass.org. Also for this and with every other session that you've probably been watching here at the PASS Virtual Summit is to make sure you still do your session evaluations. So even though we're not all in person, we still do want to get session evaluations to actually help us figure out, what's going right and what's not. And to your benefit, you actually will be registered to win some prizes. As you can see there, as long as you get your session evaluation submitted by Friday at 5 p.m. Eastern Standard Time, you'll actually be registered to win prizes that they'll have available at that time. So please make sure to fill out these evaluations. It helps PASS and it helps us as speakers actually get better with these events that we put on. All right, so here's just a quick intro to me. As it says there, Principal BI Developer with Brown & Caldwell, which I've been with Brown & Caldwell now for almost 3 years at this point. They are an environmental engineering firm focused mainly on water. So they do, designing, engineering of water pipelines and water reservoirs, waste treatment plants, all that kind of stuff. And I'm within the internal IT org within Brown & Caldwell that helps support all those engineering efforts. So building out the BI to make sure our projects are on time and on budget is one of the most important things that we track, along with some other items for HR that we do regularly in the BI space. Myself, I've been in various BI architecture and development positions over the last 20 years, pretty much spanning all the way back to after I came out of college, and working for all kinds of different industries. I've worked in the chemical industry with Dow Chemical for some years. Also worked with Visa, so I've been in the financial services business as well, and then did consulting as well for many years of my industry in both the mobile telecom, regular telecom most recently, and then also for all kinds of retail industries as well and consulting. So lots of spread out experience that's come in very handy. I have been previously a user group leader for a little over 7 years. I held various leadership positions in the local Denver SQL user group, and then also formed the Mile High Power BI user group that's actually still around in the Denver area as well. That's focused on Power BI as well. So Those have all been things that I've done over the years that I'm very proud of. And then, of course, speaking at lots of different events, such as the past summit for quite a few years, and then SQL Saturdays and other events across the world. All right, so here's kind of an intro to what we're actually going to get into within this 2-hour session, as I kind of explained. Not exactly sure where the break part will happen, but there is a little bit of talking here on just getting you oriented with what we were actually trying to do at Brown and Caldwell. So all the stuff that I'm presenting here in this session is actually all stuff that we've been working on just within Brown and Caldwell over the last little over 2 years now at this point, that we've been rolling out this new cloud-based BI architecture. Previously, when I started there, it was all on-prem, so we'll get into some of that at first. Go over some architecture, just to give people some ideas on how we had our stuff designed and how we're looking to have it designed once we get to our final endpoint, which we are not there yet. I'll tell you that right now. We're still in the process. As with most things, it's an evolving project that will keep going on for probably at least the next year or two before we get there fully. I'll also cover why we made some of the architecture decisions we did. Sometimes that can be just as important as going over what stuff is out there, is why we chose what we did, because there are so many choices out there. I'll go into some of our reasoning for why we did the things that we did within our architecture. Then I'll be able to cover some of the planning that you'll need to make sure you cover before you start something like this, just to make sure you're aware of some of the gotchas that may come up as you're going through this. So some things to help you with your planning if you plan to do something similar to this or are already in the process of doing it. And then the biggest part of the presentation is going to be this technologies used section, which is where all the demos, I'll walk through all the different tools that we used. And this is where I plan to spend the most time, is within the breakdown of all the different technologies, how you actually use them within Azure, and just give people some good ideas on how we used them to actually connect between each other that may be different than other options you've seen people use. And then after all the demos and stuff, I'll get into a little bit on source and version control, which is always an interesting challenge with any kind of business intelligence solutions. We seem to be the ones who tend to get lost or dropped off the map when it comes to having source and version control capabilities. Unlike your C# developers, web developers, stuff like that, they have some pretty good, robust tools for that. The BI tools tend to be a little bit more challenging, so we'll get into some of those challenges there. And then at the end, I'll get into some of the alternatives that we could have chosen and for whatever reason decided not to. And I'll get into exactly why we went that way. And then a nice section to cover after that will be some of the future stuff that we're planning. So some of the things we have yet to do within this architecture, and some of the things I know are coming down the road that may impact how we're going to do stuff going forward with this architecture as well. And then, as I said, I probably won't have a separate Q&A section as far as within this pre-recorded section, but we will switch to a live Q&A once I get through all these slides and stuff, and we'll do it as a live Q&A at that point. All right, so with that, we'll move into the first section, which is what I titled What We Did. So this is kind of our where we got to, so that you kind of have a picture of where all this led to over the last couple of years, and then we'll break it down from there at a higher level and drill down into each of the tools. So when I came into Brown and Caldwell, they did have an existing BI group within Brown and Caldwell. It was pretty much 2 or 3 people at the time I came in, which probably wasn't bad. At the time, it was something they did many years ago as far as spinning up a data warehouse. They did use some SSRS reporting at the time, but the biggest development they did probably within 10 years or so ago is they did build out a whole bunch of multidimensional cubes that were all hosted on premises in SQL Server. Well, when I started, it was SQL Server 2012, which has now, of course, been upgraded a little bit since then. We're still not up to 2019 and don't plan to be, because as you'll see with this, we're planning to move everything to the cloud, so we won't maintain those on-prem servers anymore. But with this particular setup, it was all multidimensional cubes, and it was multiple of these cubes. At one point, I think I counted, we had upwards of 10 to 12 different multidimensional cubes that were being used for reporting. So they had split out labor into a separate from financials, and sales was in a separate one from other pieces of reporting as well. So it made it really challenging to do any reporting across different things. So if they wanted to see how their sales were going to possibly impact financials, would be quite a challenge, usually involving lots of Excel pivot tables that would actually do lookups and stuff like that within the Excel reporting. So that was a vast majority of the reporting when I joined Brown Caldwell, was all Excel pivot table based reporting, other than the few handfuls of SSRS reports, as I mentioned at the time. So our biggest task was coming up with something that was a little bit more standardized, because of course the problem you get into with having so many Excel files running around throughout the company is that everybody can add their own little calculation to those reports and make it so the number might not be what others would expect, because they didn't, there was no real way that these calculations could be controlled within the different Excel files. So that was one of the biggest challenges, was there would be 4 or 5 different head count even of just employees. People would, have different ways of calculating it. So, that was always a challenge, is getting everybody on the same page. So our challenge was to get that, huge set of Excel files down to as few Power BI reports as possible. And also, make it so they could report across the different pieces of data, which they couldn't do with multidimensional cubes. Very early on, we decided to go down the route of choosing Power BI, and specifically at the time, Power BI Premium had pretty much just come out to be available, and we knew with it being a company of over 1,500 people at the time that we probably would have to go with Power BI Premium to avoid large costs on sticking with just Power BI and buying Power BI Pro licenses, because we do have, being an engineering firm, lots of the various people within all the different departments, of course, being engineers, are usually pretty tech savvy. So we did have a lot of people that were actually already even aware of Power BI before we started this project and had already been using it. So we knew we would need more Power BI Pro licenses than what made sense at the time. So, going with something that was a little bit more cost effective, like Power BI Premium, is basically what we decided to do pretty early on to save some costs there. So then the other problem we had, and that we've been working through, this is kind of more of a more recent development as we've gotten Power BI spun up with some stuff, is actually going all the way back to our source systems and actually redoing all those feeds in a more modern data warehousing standard. Being that the BI had data warehouse had been around for more than 15 years, it was really spread out as far as how much stuff was being put into these different tables. There was lots of stored procedures, lots of views. In fact, some of us, as we've gone to analyze these systems, finding views that are 20 deep, views calling views, up to 20 different ones. So trying to track down all the business logic was a real nightmare on some of these. So to a certain extent, we have been spending a lot more effort lately on just completely skipping over that layer, as you'll see when I get into the architecture, and going right back to the source systems, which is really important to get these new data feeds set up and get rid of some of those, what people might call black boxes, getting rid of some of that. And the big technology also that we decided on very early within this process was actually to replace the multidimensional cubes with actually a single tabular model. So, being that we were, as you'll see throughout this, trying to be cloud centric, we decided we did not really want to stick with the multidimensional cubes. There was some pain initially because there's still, even to this day, some features in multidimensional cubes that you can't do in tabular models. But the benefits that we've gotten out of going to having the ability to go to a single tabular model have far outweighed the negatives of the stuff that we're missing that we could do with multidimensional cubes now. And we found other ways around it too. So it's not like they're just missing these particular features. It's just that we found other ways to get around them that required a little bit more work than they would have if it was multidimensional. And then the biggest thing that we actually have seen the biggest results from within this last month is actually been our fiscal year end processing. Brown and Caldwell's fiscal year runs from basically kind of the last week of September. It varies from year to year because it's based on a 4-4-5 setup of weeks within a quarter. And months within a quarter, I should say. But because it's set up that way, it kind of fluctuates from year to year. But this year it fell kind of towards the end of September, so a little over 2.5, 3 weeks ago is when we went through that process. And it has been a painful process for the years before that I've been with Brown and Caldwell, and I've heard it was even worse years and years ago before that because of the way the cubes were structured. You actually had to create brand new cubes for each fiscal year. They weren't set up in a way that could handle multiple fiscal years within a single cube, and to do the modifications to make that work were just something that we did not want to invest in going forward. So this migration, as far as we've taken it within the last 2 years, has gotten us to the point now where our fiscal year-end migration for this last fiscal year, for our fiscal year 20 going into our fiscal year 21 now, has actually been a tremendous difference in time, going from many man hours, man weeks of data down to just maybe 1 man week or something like that. I think we haven't gotten the full statistics yet because we didn't calculate everything, but the level of effort within a development team has gone down tremendously. So just this new architecture has really made that much better. And then we also have, spent a lot of time making sure that the rollout of Power BI was as smooth as possible to everyone, and that they understood what it was for, who could do what with the tool, and all the pieces that go along with that. So we've been working that through for a little over a year now. And at this point, it's actually been very successful. As I kind of point out at the end, we see pretty regularly that we've got, a good chunk of the company. We're not there at 100% yet, but we're working towards it to try to close those gaps. But most of that's just because our current tabular model is still growing into new sections of the company. We've been purposely just adding small iterations of changes to the model over time, so we don't have necessarily everything that everyone would use, but we're working towards that. So once we get to that point and can build new Power BI reporting off of that model, that number should be near 100% usage. And everything we've heard from all the users so far has been extremely positive, and we've, knock on wood, not had any issues with systems going down or anything like that as well, which is great. All right, so the next section we'll get into is kind of some of the architecture, how it was and how we wanted to see it set up, so how we had designed it, and then kind of also give you a higher level one that's a little bit less noisy, because some of these architecture charts get a little crazy, as you can imagine. Here is what we were shooting for, just to kind of give you, this is what Microsoft has put out there that you've probably seen in multiple different forms over the years of what they see as the modern data warehousing architecture for companies. So You know, your typical setup where all of your source system data all lives, you know, on those systems, and that's not changing. But the idea is, how do you get that data into a new setup? Their recommendation, which is also the way we are doing any of our new cloud first scenarios, is using Azure Data Factory, which you can think of as your, if you've used SSIS or SQL Server Integration Services, that's kind of what this is in the cloud. And in fact, they've updated this tool over the years to actually even have the ability to run your actual on-premises SSIS packages within Data Factory. We talked about that scenario as well and decided against doing that, just because, as we said, we've had years and years of buildup of lots of stuff that we aren't, able to support as easily anymore. So we've decided to go down the route of pretty much completely build brand new ETL or ELT processing, and all of that now is being built within Data Factory itself. And then from there, we are using Azure Data Lake, actually specifically more Azure Data Lake Gen 2. For those of you that are familiar with the different storage technologies built into Azure, this is the latest one that Microsoft's put together that brought together what was Azure Data Lake Gen 1, which was their first move into this hierarchical data structure where you have folders, metadata describing the data, and set up like that, just built on top of just very large file stores. Gen 2 kind of merged what they already had with blob storage in Azure, and what the hierarchical namespace, the benefits it brought with Azure Data Lake Gen 1, and brought those both together, and that's Azure Data Lake Gen 2, which is what we use as our data lake as well. There is the capability to use the Azure Data Explorer, which we'll get into in a little bit as well. That's something that's built into Azure. The technology here is kind of changing to a certain extent, but if you needed to have data scientists, people like that who have more advanced needs for data, the idea being they would have the ability to access this data lake storage to get to the type of insights that they need just by exploring the data in its raw form. Not something we're actually doing at this point in time, but it is something that we definitely know is out there, especially as we get into machine learning and AI type stuff. That's kind of where that comes into play. And then more of your traditional transform type capabilities in Azure Databricks. Again, this is something we are also using as well to do basically our actual transformations of the data and actually getting it loaded into our new data warehouse. So in this particular architecture, of course, Microsoft is showing what was called the Azure SQL Data Warehouse at the time that this particular architecture diagram was put together. That has now since changed to Azure Synapse Analytics, and specifically in the sub area called SQL Pools, if you're interested in that technology. And I'm sure there's tons of sessions available at the past virtual summit this year as well that actually highlight that particular change in technology there. But if you're interested, check that out. We actually decided not to use this technology for this piece of our puzzle. As you'll see when I get into it, we're actually going to be using Snowflake, which I'll get into. Still runs natively within Azure, so we're still within the Azure stack, just using a different third-party tool as our actual data warehouse. And of course, it's missing the one piece in here that's a semantic model. If you've heard of that term, kind of the single source of truth type of scenario that we actually have built into ours, as you'll see, that would be SQL Server, Azure SQL Analysis Services, that's in between there, that sits on top of the data warehouse and to a certain extent the data lake as well, and presents a unified reporting layer for Power BI, which is kind of the way we went with this. But that gives you an idea what Microsoft was thinking of at the time, and some of this stuff has changed over time, so you can keep up with that on Microsoft's website as well. So here's kind of our crazy diagram. This was a diagram we actually put together when we first started going down this entire road, and it's actually changed quite a bit as we've gone through it. But this, what's below this line here, is kind of trying to show where we were 2 years ago with all the different setup of things, where all of these source systems, to a certain extent, were flowing data into these other databases. These two databases here kind of worked in unison. And this is where I was talking about with a lot of these 20-layer deep views, lots of stored procedure calls and stuff with logic that nobody in the company is around anymore to understand or know why they did it that way. So this was our biggest stumbling block, was finding out a way to get past that. So we'll get into some of that as we go on. More recently, this actual data warehouse was built. It's probably about 5 years old, I would say, at this point. So still before I got into the company, but it was created as a true star schema data warehouse. So it was set up more like what your traditional Kimball-based data warehouses are, with dimension and fact tables and stuff like that. So it was set up a little bit more on a modern standpoint, which is good, because then they, of course, built multi-dimensional cubes on top of that, which, and then as I highlighted, those were used in Excel reporting. And we even had ProClarity, which as of, I think, probably here in the next couple of days, as I record this, we'll finally be turning off our ProClarity servers, which is great, because that thing's been out of any kind of service from Microsoft now for I don't know how many years it's been. It's been at least 5 or 6 years that ProClarity has been deprecated as a tool at Microsoft. So we're going to be glad to turn those servers off next week. Fingers crossed. But yeah, so the big thing was to go to this top part, which is kind of what we're calling our future state of setup, which I kind of already highlighted a lot of this as we went through the Microsoft version. But the first thing we decided to do was use a source that we had not previously integrated into this existing architecture. Our HR data was being fed to us through some of these other feeds, but it wasn't a pure view of the HR data. So our first thing that we wanted to do is actually get a pure, straight from the source, Ultipro version of the data, which is what our HR team uses to track everything that has to do with employees, from training to compensation to anything that has to do with an employee and their journey within the company has all been tracked within Ultipro, which we actually internally renamed at BC to be called Talent View. So that's kind of where that came from. So we wanted to take those feeds directly from Ultipro, feed them into our new data lake that we spun up using the Data Lake Gen 2. From there, try to get it loaded into a data warehouse, a new data warehouse. And this is where Snowflake comes into play. We decided to use Snowflake for that technology after an evaluation and POC period. But that's, we'll get into that as we go through the technologies on why we made that decision. But this would be Snowflake. And then from there, using, as I mentioned, Analysis Services tabular cubes in Azure. So this was always a cloud native setup for these tabular models going forward. And it's a single tabular model. It was the idea. We've since spun off a second tabular model that's actually just a very small model that we use to track just internal IT type related information that we don't need the whole company to see. So there are 2 tabular models now in use at BC. But from there, the idea was then everybody would use those tabular models to build various reporting within Power BI and to a certain extent Excel, trying to get a lot of people broken from the habit of using Excel. But as most of you probably know, that's been extremely difficult to get through even to this day. But we do support capability of still using Excel reports, just trying to help them with having some more standardized Power BI reports out there as well. And then within this, the symbol here is kind of indicating this is Data Factory. that's helping orchestrate all of this, whereas it was SSIS down here below. This is all done with Data Factory, calling out to Databricks to do stuff as necessary. So that's kind of how we wanted to see our architecture set up. And again, this is a higher level view that just gives you a little bit easier way to see what specific tools we're using for our different layers. Again, just showing you with the UltiPro using a secure FTP setup that we have with that vendor. We actually go and get all of the files from them each night, load them into our data lake using Azure Data Lake Gen 2. Then that gets loaded into Snowflake using Databricks to do the transformations and the loading into Snowflake. And then from there, the Azure Analysis Services model is pulling all the data in from that Snowflake. And to a certain extent, we're still pulling, as you might have seen on that on this previous diagram. There is still this dotted line coming from the existing SQL data warehouse that is still on-prem into the tabular model as well. And then the idea being that eventually we'll be able to erase that dotted line as we get everything going up into this top half is kind of the idea over time. So yeah, the tabular model here actually connects to both Snowflake and to the on-prem SQL server at this point in time to present all the data, because we don't have everything in Snowflake to do that yet, but we're getting there. And then, of course, from there, using Power BI to be the reporting tool of choice, basically on top of that analysis services model. All right, so that got us through kind of the architecture, why, the decisions we made. I could probably spend hours just going through all the different POCs and the different things we did to actually go through this. But actually, I did do a session at last year's summit, if you have access to those recordings, where I actually did go through a little bit more of the POC process, the getting the project approved to actually do a lot of this work that has continued through this last year and probably will continue for at least the next year or two. So if you're looking for more details on that, hopefully you can get the recording of that from last year's past summit as well. So why did we make some of those decisions that you have heard me talk about through the different architecture setup? The biggest thing that was driving us from the very beginning, working with my manager, was that the first thing that was brought up when I was brought in that I loved, which had been very difficult to find up till now. Now, pretty much every company is kind of looking at this, especially with COVID, is that we wanted cloud-first BI. As with most companies, probably a lot of stuff was on-prem. It was getting to the point where just maintaining all those servers was a challenge. So wanted to get off of it being on-prem and get it into the cloud, mainly for the cost savings for us. We're not a super large shop. None of the stuff that we're doing is big data in any means, at least not yet. There is some future growth possibilities that we can see coming down the road that might lead us more into big data as we work more and more with some of our clients. As you can imagine, running some of these water systems, we are getting called on as a company to help some of these municipalities that support these water treatment plants and water pipelines to be able to monitor, as you can imagine, everything that's done within these plants. And so that is something that we could see coming down the road that will also help being a cloud-first BI as well, because the cloud can easily handle those kind of growth spurts much easier than on-prem. So that was one of the main reasons we wanted to go cloud first. Early on, we did choose Power BI. We did have an evaluation period on reporting tools. Tableau was on the table, as I'm sure it is with most people who look at any kind of web-based, cloud-based reporting solutions. But when we did the numbers for, as I mentioned, the number of people who might be developing reports to buy all the licenses with Tableau for that was going to be astronomical in comparison, a factor of 10 or more in costs for us is what we saw, and we're working directly with Tableau to figure out what kind of discounts and stuff we could get. At that time, Power BI just made more sense, and still to this day, we have not regretted that decision. It's still been by far the best tool we could have chosen for the architecture we're building out, and with the number of users that we have. So definitely something to consider as you're going through that. We also wanted to do something that would be easy enough to learn for all of our people within our team, and be able to teach it to others. That's the other great pull with Power BI that's out there, is even for people who are non-IT based, it's been extremely easy to train people out there on how to use the tool, especially with having this single model that we currently have to connect to for reporting. Has made things super easy to teach people to go and get the data they need and report on it, which has been an amazing change in the company from what it was before, where there were constant asks of the BI team of, where can I get this data, where can I get that data? As we start closing the loop on more and more of these source systems, everybody's finding that everything they need is all in this one place, which has been really great for us. And then, of course, we want to make sure that whatever we choose is going to be flexible going forward. You don't want to choose something that you're going to regret choosing and then have to switch right away to get off of it onto something else. We did look at AWS as well as the cloud solution, brought them in, did some POCs on some of their technologies as well, and just decided for our company, sticking with Microsoft and Azure was a smarter solution. The company was already very heavily invested in Microsoft technologies, lots of SQL Server, on-prem licenses, no Oracle really to speak of at all. So it was, a fairly easy shift to say that we wanted to use Azure. And in fact, our infrastructure team even went down the road of saying, well, we're going to, spin up the infrastructure, networking, and virtual machines and all that kind of stuff in AWS, and have since backpedaled and actually decided to switch from AWS into Azure, which we've been using from the beginning for the BI teams. Some interesting things. I wasn't in on all those decisions from the infrastructure team, but it was interesting to see that they had to pivot within the last year away from AWS and into Azure. I think mainly just because of costs. Since we have so much with Microsoft, we've been able to get some really great discounts. We actually also this year, very well timed, actually, the rollout was in the January-February timeframe of 2020 for Microsoft Teams as our main communication platform for the entire company. And the timing couldn't have been more perfect, because literally within a month of rolling out Teams to the entire company, we all started working from home. So we were able to make the switch to 100% on work from home for the whole company with little to no downtime for the company, which was just amazing. So it just kind of proved itself as far as sticking around with some of these technologies that we were all familiar with from Microsoft. And of course, with everything, you want to make sure you can add new stuff. As I mentioned, the team stuff that we actually just did, and some of the built-in capabilities we're getting between Teams and Power BI right now are just going to blow everything out of the water, where people used to have a separate browser window open to browse their Power BI reports. Now with the new Power BI app that's built into Teams, they can do everything right into Teams. It's like Teams is becoming the new SharePoint or the new Outlook going forward, where everything just lives in that single pane of glass, which is just pretty amazing. And we did also fairly early on, about the same time we had made the Power BI decision, reporting, had really decided we wanted to go with Snowflake for our data warehousing technology. Again, mainly just because of cost for our size. We had a hard time even getting Microsoft at the time to talk to us about what was Azure SQL Data Warehouse at the time, before it had been renamed. They pretty much say that you need to have at least 2 terabytes or more of data before using that technology really makes sense to you. So our choices were pretty much down to, using any of the other SQL-like tools in Azure, whether that be MySQL, dedicated SQL Server capacities within Azure, SQL DB that's run as on the infrastructure within Azure, or going with something like Snowflake, which was a fairly new option in Azure at the time we were making the decision. In fact, we were on Snowflake to do the POCs basically in when they were just starting up their instance within Azure. So we got to kick the tires on that one as it was just starting to roll out within Azure, and I've been really happy with it ever since. Some really great benefits that we'll get into as we talk about the actual technologies here and start demoing the products. But great tool for not necessarily requiring terabytes and terabytes of data as Azure SQL Data Warehouse or Synapse Analytics might require today. So definitely something to look at, and we'll get into that in more detail later. And then I've mentioned over and over, everything we made decisions on needed to be reasonable within our data size, because we are not doing big data. But having the flexibility to do big data was also a big part of it as well. So that's kind of why we went down the roads we did. All right, so next, getting into some of the planning stuff that you may need to think about if you're on a similar journey and actually need to start looking into how you're going to build out some of this type of architecture and some of the decisions you might want to make sure you're aware of ahead of time. So the biggest thing, especially if you're going to choose Azure, and it kind of applies to AWS as well, is where are you going to kind of make your home region, or your main region where all of your or a lot of your resources are going to live. I mean, that's kind of the great thing about the cloud, either Azure or AWS or even Google Cloud Platform, is you get to choose, kind of where you want your data to live. As far as different data centers and regions within each of those products. It's kind of a little different with Azure because of how they've integrated in Office/Microsoft 365, whatever they name the tool next, but basically your main Office tools, Teams now is part of that as well, and then Power BI. If you're already using Power BI, what tends to happen is the first person in your company, when they sign in to create either an Office 365 or even spin up a Power BI instance, even the free instance for your company, is it's going to be based on where in the country or world that particular user is that does that first spin up, which is the interesting thing that most people don't know, is that as soon as that first person activates the account, it says, okay, they are here. This is now, quote unquote, your main or home region. In our case, our headquarters are in Walnut Creek, California, outside of San Jose, California. So when that first person signed in, the West US region was immediately selected as our home region. So not a huge impact, but just some things you have to think about, because as far as I know, with all the cloud providers, they do charge you usually a negligible fee, but they do charge you a fee when you're actually transferring your data outside of those regions. So, you want to make sure that home region is going to be where you want it. Not sure how hard or easy it is nowadays to move that home region within Azure. But I know that our infrastructure team, when they moved back to Azure from the AWS, they wanted to choose South Central. The South Central region within Azure is kind of their home base for stuff, because it was more centrally located in the US. Most of BC's business is all US. We have a couple offices in southern Canada, but 98% or so of the company's resources are all in the United States. So they chose that South Central region for their stuff, but we now have to keep in mind that pretty much our Power BI, our main Power BI premium instance itself lives in that West US region within Azure. So anything that's in a different region from that's going to be paying to have the data moved across from it. Not that it's necessarily a big deal, as I said, but it is something to keep in mind that it is something that you will pay for. The other thing I'll highlight is that not all of the different technologies available in Azure are available in all the regions. I actually have a diagram here, and that link actually works in the slides. When you go to download the actual slides from this presentation, you can get to this link, but this link actually highlights and is updated regularly from Microsoft what technologies are available in what different regions and data centers of the Azure cloud. So you can see here, we can say we're just going to look at the US regions, which gives us the 9 different data centers. Here's that South Central one I mentioned our infrastructure teams using. Here's the West US, which is the main one that our Power BI and Office 365 runs off of. And then you can see from there, okay, Databricks, well, works in South Central and West, but not West Central. So these are the kind of things you got to keep in mind, is that not all of the technologies are available in all of the regions within Azure. So that's just something to keep in mind. The left side here is just, it's everywhere, basically. They're saying these are non-regional, so they're available in all data centers. But just something to keep in mind for the different things you're going to choose. You will notice that most stuff is available in all of them. There's only a few holes, and they constantly are working towards getting rid of all those holes. Data Factory, I should also mention, has gone from a V1 product to what they just call Data Factory, but is technically a V2 version, which is what we're using as well. As you can see, it's available in a lot more data centers. In fact, all the data centers in the US, but the old version of Data Factory wasn't as well supported. Same problem for Gen 1. Azure Data Lake Storage Gen 1 is actually disappearing more and more as it's been replaced with the Azure Data Lake Storage Gen 2, which actually just lives on top of standard Azure storage, which is why it's available in every single data center across the world. So that's the huge benefit of using Data Lake Storage Gen 2 is it's just available everywhere. So those are the things to keep in mind. Good news is now at this point, the Azure Analysis Services is available across the US and all data centers. At the time when we were evaluating and doing our POCs, that was not the case. It was only available in a handful or a few of these regions, but now it's available in all of them. So that's a good thing as well when it comes to that. So just feel free on your own, check out this. It even breaks it down by the VMs and the different sizes of the VMs, which is great. So if you need some super large VMs or some very specific ones with GPUs or stuff like that, those are the kind of things you need to look at and make sure you're picking the actual correct data center for your specific use. Okay, and then the data going in and out, as I highlighted, and then sizing of the resources and the features available. That's another big thing to look at. This was one of the main reasons for choosing Snowflake, actually, as well. Some of the resources in Azure have the capability of doing instantaneous, being able to spin up more compute or spin down dynamically when you're much compute resources for queries. That's built right into Snowflake since it was built from the ground up as a cloud-based database, data warehouse. It separates storage from compute, just like most stuff in the cloud that you'll hear about today does that. But Snowflake's one of the few that has the ability to dynamically allow you to resize your actual compute without having to lose any queries or wait for a query to, a super long running query to finish before it can do the resizing. It can do it instantaneously without any downtime on your queries. So that was a huge plus for Snowflake at the time when we did that. So those are the kind of things you need to look at as far as sizing of stuff in the cloud, of course, you can get far, far more compute power if you're willing to pay for it in the cloud than what you could build on Prem. And the nice thing is like I said, in most cases, like even the SQL Server, we use mostly the Azure SQL DB, which is just their fully managed version of SQL Server. We can size that thing up and down dynamically. Same for our Azure Analysis Services. If we want to scale it up, in fact, we have it built right into our Logic Apps that we use to actually process our model. You could actually say, okay, when I go to process this part of the model, scale this thing up to an S3, which is a factor of 2 times factor bigger than what an S0 or an S1 is of it. And then when it's all done processing, it'll process it that much faster because there's that many more cores and memory dedicated to it. Then at the very end of the processing in the Logic app, it'll actually spin it right back down to where it should be for normal running. So that's something that is easiest to do in the cloud by far because the tools are being built to support that, which is great. And then as with most things, security is always a big requirement. And, Microsoft has been pushing on, and Google and Amazon as well with AWS, that, the cloud is as, if not more secure than your own on-prem data capabilities for security are. None of those data centers that are out there for Microsoft, AWS, or Google typically don't have any human presence. They're all automated data centers with very few, if any, humans on site within them, and then they've all gone through whatever certifications they need to basically get the full sign stamp of approval that they've got everything worked out on all systems, because they know as soon as the first things come out about somebody hacking across different companies that are hosted in Azure, that it's going to kill the system. That's why it's in their best interest to make sure it's as strongly built as possible. So all that stuff is actually built right into the products. All right, so now we will move into highlighting each of the technologies. And based on where we are timing-wise, I think I'll highlight the list, and then we'll probably do the break at that point because we should be right on to the first hour of this session. So it's going to work out as I expected. All right, so here's a list of all the technologies in Azure that we're currently using today for our BI solution that we've built, as I said, for years. And I'll highlight some of these in more detail than others because they're just not something that needs a real deep dive on them. But I will definitely highlight for sure the Data Lake Gen 2, since that's a big one. Data Factory V2, the Databricks is something very easy. Then we'll get into, I'll do a little bit on Azure SQL DB. It's really just SQL, an on-prem SQL instance running in the cloud, completely hosted by Microsoft, that you don't have to buy separate licenses for. So we won't have to highlight that since I think most of us are very well aware of how Azure SQL works. Then we'll get into, of course, Snowflake, which will probably be what a lot of people want to hear about. And then I'll also highlight Logic Apps and Runbooks, which is just another capability for you to kind of run low code, no code scenarios. Something where you may be running PowerShell today. In fact, Runbooks, the Runbooks we do in Azure are all PowerShell Runbooks. But these are just capabilities to basically run something on a schedule or have something be triggered to do things automatically within Azure that kind of had the reach to span across the different applications in Azure is kind of what those are great at doing. They're kind of like the glue between all these different tools in Azure. Then we'll get into Azure Analysis Services, which we are currently using, and I'll highlight in the future section, some of the stuff that's you may or may not be aware of with Power BI Premium that are coming very soon that will, if all goes well, within the next quarter, calendar quarter, hopefully by the beginning of next year, 2021, we'll be able to migrate actually our Azure Analysis Services models into Power BI Premium is actually our plan. So that's one of the boxes that will probably go away first within the scenario, and I'll get into that once we get into those different changes that we know are coming with Power BI Premium. But then we'll also highlight Power BI Premium as well, as I mentioned. All right, so with that, I guess what I'll do real quick here, since I got a couple minutes, is just highlight the Azure Portal. So for those of you who actually already have an Azure account, you should be very familiar with actually all this different capabilities within the portal. But you just go to portal.azure.com, sign in with your company's login, and then you'll be presented with a different dashboard. This is actually my personal dashboard. Typically, it's not actually switching, but there's usually a standard dashboard. I've modified this, so I'm actually showing our live monitoring in this dashboard, in this case on our Azure Analysis Services instances, just to kind of keep my eye on the memory usage and the CPU usage and all that kind of stuff. And then I also added a list of all our different resource groups within this. But this portal, when you start working with Azure, is kind of where you start living in this web UI to actually build out all your different setups and your resources within Azure. But the main concept to keep in mind is they have what they call resource groups, and this is kind of your highest level than your subscription. Your subscription is your main account, basically, with Microsoft. But then within a subscription, you can have as many of these resource groups as you want. In our case, we decided to, as you can kind of tell, split them up by like environment. So we have our dev, our test, our proof of concept, or our kind of our play area or sandbox. We have a kind of a parallel production instance that we spun up initially, and then we have our production here. So we kind of have that broken down by those different resource groups. And as you'll notice, a lot of them are still in East US 2. That is a kind of a throwback to when we first started doing our POC in Azure. Most of the resources we needed were only available in East US 2. It's only been, within the last year and a half or so that we've gotten everything we need in West. And so even when you go into these resource groups, you'll see that a lot of our stuff is actually in a mix between the East US 2 and West. And a lot of it is migrated more to the West. And that'll be the plan, is eventually we'll go through and actually migrate the rest of these into West. So that we have pretty much all of our BI stuff all in one place. Because the thing you have to keep in mind is if you're spread across multiple data centers, especially for something like an Azure Analysis Services instance, if you're going to try to get to on-prem data with those Azure Analysis Services to do refreshes of data, you're going to have to set up data gateways to get to those on-prem resources. And those data gateways really need to live in the same region that the actual analysis services instance is in. So, that's kind of one of those games you get into, is that the gateway is really just there to basically be the go-between from the cloud to your on-prem and negotiate those connections through a secure method, giving you that secure passageway from the cloud into your on-prem SQL servers or any of that setup. But yeah, that's kind of the gist of the beginnings of what we'll get into with the Azure setup. But as you can see, we have, even just in our dev environment, quite a few different services deployed already out here to make all this work. So keep that in mind as you're deciding how you're going to set up your resource groups, as well as that there will be lots of different services you're going to need and pieces of the Azure cloud that you're going to have to keep separate within this. So those are all things to keep in mind. Starting with the Data Lake Gen 2. So this is kind of what everything is built on from the very beginning, is that you need some kind of place to store all your files. And they've created these, what they call data lakes, started out in Azure as blob storage, which is just a place to store any kind of file or piece of information in a cheap manner. They integrated that technology with something they had developed separately called Azure Data Lake Gen 1 initially. That was a hierarchical based namespace with folders and other metadata describing the actual files. They merged those two technologies together, and that's where you got ADLS Gen 2, which is now available basically everywhere. Azure is available now, which is great. The other great thing about it was it's made to be super cost effective. So you're really just paying pennies per gigabyte of storage, or fractions of a penny, I should even say, in Data Lake. It's by far our smallest cost, actually, even though we have more stuff stored in our data lakes than we do anywhere else. It's actually the cheapest cost we pay for in our Azure monthly bill, which is interesting. But it's also because of the integration with the data lake technologies allows for big data and analysis capabilities. And there's a link here if you're more interested in that setup that you can get into, where it talks about the actual blob storage, blob file storage mechanisms, and how the querying with Hadoop in the background actually works with that technology. That's something I'm going to highlight here, but if you are, a data scientist or looking for something about how that works, that link there within the slides will help you there. If you are going to start using a data lake, kind of the tool that Microsoft puts out there for you to actually be able to browse your data, upload, download data into your data lake if you want to do it manually, is actually the Azure Storage Explorer, which is a free tool that they've put out here for those of us to use that are using data lakes. As you can see here, this is the tool that is a Windows desktop tool that you download. And then it just allows you to browse by your subscriptions that you have in Azure, and then connect into each of your data lakes or your blob storage accounts that you may have in Azure, and you can browse the various hierarchical setups. If it is a data lake, you'll see them as hierarchies with folders that you can drill down into, and you kind of see, in our case, what we do is try to set up these folders to be something that's easy to find what we need. Being, the idea being we have our basic area is raw for any file that's just coming in unprocessed, a staging area if you need it to do manipulations of the files, and then the archive area is after the file's been processed in raw or staged, the idea being it gets basically archived into the archive scenario setup. And then from there, we have like a system or a source folder that they all go into. Some description about what the file is. If there's, in this case, there's multiple different ones in our setup for this data coming from different places. So we set up a folder for each. And then the standard that's kind of out there on the web that people use for their data lakes is a folder for year, a folder for month, and a folder for day. And then you dump your files that are processed on that day all out here into a folder. In this case, this has got a mix of XML and CSV files because the source files that actually came into raw were actually XML. So all those files are archived here. And then we do actual differences as we load it into the data warehouse and dump back the CSV or Parquet files, in some cases, back into the archive area of our data lake as well. So if we need to restore stuff or some load goes incorrectly, we can actually easily and quickly get back to it through using these folders. So that's kind of the setup with our file system within Azure. Very easy to use, very simple use, but very powerful at the same. Key Vault. So Key Vault is a tool for those of you that are familiar with other tools out there, like LastPass might be a tool you're familiar with that LogMeIn purchased years ago. It's a tool for you to store your web passwords and user IDs. This is kind of the same thing, where it's an encrypted storage area within Azure that you can store those kind of passwords, connection strings, things that you may not want everybody in the company to have access to, that you need to hide. But your different resources within Azure, like your Data Factory and your Databricks, do need to be able to read those in to connect to different resources. You store them in here in an encrypted form, and then those tools would have the rights to go in and read those secrets, pull them out, be able to decrypt them, and use them to connect to your resources. So yeah, really nice way to store that type of information, fully supported pretty much across the board with a lot of the different resources in Azure. And then you can grant security access to the specific secrets and keys even, or the whole key vault as a whole, as to whether a developer can even get in there and actually even see anything in the key vault. Or you could grant them access to just the secrets they need to see to get their application running. So lots of granular access built into that, to the key vault. The key vault is accessed only through the Azure Portal, or I mean, if you wanted to do PowerShell and stuff like that, of course, you get to it that way too. But from a GUI standpoint, you pretty much get into it through the portal. Over here on the left in the settings area, you'll see there's the keys, the secrets, and the certificates that you can set up to store within your specific setup. In our case, we only use secrets, which is really just a key value pair. So you assign a name, a unique name that you're going to use to identify whatever this password or connection string is. And once you store the name, then you store a different key in it. In this case, this one has 2 versions, so you can actually version the different values. So you can look at an older version. If you click on the show secret, if you have the rights, you can actually see the value. Otherwise, you'll just see an encrypted string. But then you can also look at, if it's been updated, it'll have a newer version that has a different value in it. So that's kind of the cool thing about those particular setups, is that you can keep kind of a history of what the values were if you need to. And then the applications or resources like Databricks that need to access these can be set up to always just go to the current version, or they can go to an older version if they need to pick up the correct value, as long as they pass in that unique name that you assign to that particular secret. So really quick and easy way to store stuff, like passwords is the easiest way to think about it, to use within your different resources in Azure. So we use that a lot. As you can see, we had a lot of different keys stored in there, and we have them broken down by those environments, like I pointed out in the first part about the resource group. So even though the names of the keys might be the same or will be the same in our dev, test, and prod resource groups, the values, the actual secret values, are different between those different environments, because then they're specific to that particular environment as to the password or value for each of those different environments. Okay, Data Factory, as I mentioned before, is kind of our ETL or ELT. It's kind of the newer words for extract, transform, and load, or extract, load, and transform, depending on which way you do it. Kind of the newer way with the modern data warehouse is an ELT. You're extracting the data as a flat file, loading it into some place, and then transforming it after the fact, rather than doing the extract, the transform, and then loading it into the database. Just a slight difference in how the processing order is done. But yeah, I like to think of this as the SSIS in the cloud, since I used SSIS for, probably more than a decade. It reminds me the most of that tool. The idea being that when you build it, it's no code, very similar to SSIS, unless you really want to get down into the nitty gritty and execute some C# code. That capability exists in SSIS, and it also exists in Data Factory if you need it. You can run your actual SSIS packages in Data Factory v2. You do have to have a place to store those SSIS packages in the cloud, so you are going to have to spin up some kind of a SQL database resource to actually put your SSIS packages into the cloud, so that your Data Factory has access to them, but they've opened this up quite a bit more than what it used to be. It used to be a lot more difficult to get those SSIS packages into your cloud setup. Now you can actually just spin up an Azure SQL DB, the platform as a service version with an SSIS DB set up in it and put your packages in there. So that would be the cheapest, lowest cost way to do that if you needed to. It has the capability to be triggered for scheduling, so on a timer schedule, or you can actually trigger it from outside within. As we'll see, we've got stuff where we've got different Logic Apps and stuff like that within Azure that can trigger a Data Factory pipeline, or you actually can, just run them on a regular schedule. They also now have the capability to do what they call data flows, which are, not equivalent, but similar to data flows in SSIS, if you're used to that kind of naming. They've come up with two different technologies so far for this. They have what they call mapping data flows, which is more of your traditional SSIS type of data flow, where you've got these different transformations that you pull in to, change the data, add new columns, stuff like that, using just drag and drop. And then they have wrangling data flows. So if you're more proficient in Power Query and used to how, if you've used Power BI Desktop and gone into the actual transform data section within a data source, you know how to use the Power Query and the M language. That's actually what wrangling data flows is, just a web version of that same technology. So you could actually, if you've already written, some of that kind of those kind of transformations in Power BI, you could easily just move those over into a Data Factory wrangling data flow is what they call it. And then you might possibly need these integration runtimes that you'll run in your on-prem environment that basically act the same way as a data gateway or the Power BI gateways that basically can reach into your on-prem data sources as necessary to reach to grab data out of SQL servers on-prem and stuff like that that you may be using within your Data Factory. So just know that that's something that may be required as a separate resource as well. All right, and with that, we'll switch over to Data Factory. So Data Factory has a resource that shows up here within the portal, just like anything you spin up. But as far as actually where you edit your pipelines, as they call them, you have to click this link within the portal. And when you click that link, it actually opens a completely separate tab for the editor that is the Data Factory editor within Azure. And this is the normal home screen. It has some tutorials, some videos for you to get started, which is great. If you've never done it before, great way to get started. There's where you can do some of the configuration of the SSIS integration I talked about, is just clicking on this little link there. If you want to do a real simple copy, this is probably the easiest way to learn how Data Factory works. If you want to just do a little test copy pipeline to actually pull data from one source into another, I recommend trying out doing a copy data to see how it works. Gives you a really good idea how to create a simple pipeline. Otherwise, you can get into the actually building a pipeline or a data flow as necessary, and then once you get to a scenario where we are, we have 78 different pipelines right now at this point, with 99 different data sets that we connect to on a regular basis. So, you build out stuff pretty quick within Data Factory, but, just to give you kind of an idea of what a sample pipeline looks like, this is a fairly easy one to kind of get an idea of what it does, but it looks a lot like a control flow within SSIS, as you notice, where you've got your, capability to drag and drop. All your drag and drop items are over here in this little toolbox on the left. But you can kind of get an idea of the different type of things that are available to you. You can call other data flows. You can call other pipelines. You got the execute pipeline task to actually go and run other pipelines. Stored procedures, if you need to call a stored procedure in SQL, that's right there. If you need to do a wait, there's an iteration control, so you can filter data for each, if, switches, and until. So they've got most of the iteration type conditional stuff covered. And then you can also do any kind of some machine learning tasks as well, which is great that that's all built in as well. But yeah, real simple. You just put the different components onto the page, configure each of the components. So you have a pane when you select them that lets you configure the different options for each of these. This is kind of where that low code, no code scenario comes from, is that you're just passing in the different pieces and then it does the work for you. So yeah, all kinds of different ways to do stuff that you can get into pretty easily, pretty quickly. The trigger capability is up here, where you can just add a trigger on a pipeline, either manually just run it now or create an actual trigger that's either, like I said, a schedule or an event or something like that that can actually trigger these pipelines. So yeah, that's what data pipelines are for. All right, Databricks. So the main thing that we, instead of doing data flows, as I mentioned, we use Databricks to do that work for us. And what Databricks is it's Apache Spark was where it started years and years ago, probably over a decade ago at this point. But Databricks has been around for a very long time, which is the nice thing about it. There's tons of help online because it has been around for so long. But yeah, the Azure Databricks is basically just the implementation of the standard Databricks that's out there. So if you go to databricks.com, it's actually a third party, just like Snowflake is, that is fully implemented within Azure. The nice thing about Databricks over Snowflake is that you don't have to have any kind of a contract with Databricks directly. That's all built in to your resource. When you actually spin up a Databricks resource in Azure, they do all the stuff in the background as far as paying the license fee as necessary to Databricks. Whereas Snowflake, you actually have to have a contract with Snowflake, and then they allow you to use the resources in Azure or AWS or GCP, as we'll get into in a little bit. But yeah, Databricks is basically just a way of running a cluster of compute that actually goes out and does work on your data. Used a lot for machine learning and AI capabilities. That's all built right into Databricks. That's something that it's been doing out of the box for many, many years now. So if you are looking to do those type of workloads, I would strongly recommend looking into Databricks, because a lot of that stuff is very well built into Databricks from the ground up. So you don't have to do a lot of the manual work you might have to do if you were trying to use some other technology. The other nice thing is you got lots of different language support within Databricks. You can do Python, Scala, R, Java, and SQL. Soon, .NET. That's something they've announced, that they will have .NET language support coming soon. I think starting with C# next year. So if you do have C# experience, that'll be great to leverage that within Databricks as well. It uses what they call notebooks. You may have heard this terminology of Jupyter notebooks, because it started to be supported within some of the SQL tools to actually do Jupyter notebooks for your SQL Server queries. Instead of just storing a whole bunch of SQL files, you can actually use a notebook to contain multiple queries and kind of have the notes and all that kind of stuff along with it, which is really nice. So this is kind of where that really came from. It started with Python, with the tools for Python, but it's been fully integrated into Databricks as well. And along with those notebooks then being able to be stored and source controlled through GitHub and Azure DevOps, which is great. And the biggest thing for us was the built-in support for Data Lake Gen 2 and Snowflake is built in right out of the box with Databricks. We didn't have to go and do a bunch of stuff to get those technologies working, which at the time when we did this a little over a year and a half ago was a big deal, because there wasn't a lot of that support baked into all the different tools in Azure at the time. So Databricks. Again, similar to Data Factory, you will see the Databricks resource within your portal. Once you spin one up, it's got the same little symbol that I show. And when you click on that, you really don't have any capability to do anything with your Databricks inside the portal. You have to click this launch workspace, which then opens its own separate tab with its UI as well. So that's kind of the downside to these tools, is you're opening a lot of tabs in your browser. But I've gotten used to using, especially in Chrome, the pinning capabilities, and you can just pin these once you've opened this up, connected to whatever environment. In this case, my dev environment, I can just pin it, and then it's just always available to me. I might have to click the button to sign back in with my credentials, but other than that, it's automatically linked up to dev for you, which is nice. Again, just like Data Factory has some nice quick start, get you going type scenarios. So that's easy for you if you're getting started. Otherwise, you can go into, if you've got stuff, into your workspace. In this case, we've set up, you can have, each user has their own workspace, or a shared workspace if you're working with multiple developers, kind of what I recommend. And then you have your list of all your notebooks. And you'll notice, even though we had, tens of different data factory pipelines, we only have maybe 12 different Python data notebooks for Databricks, which is the great thing that we've gotten into with using Databricks, is that it's much more configurable to be able to reuse a lot of this Python code, which is the great thing about it. So, here you can see there's a bunch of parameters that you can pass in. In our scenario, these parameters actually all get passed in via SQL queries. So our Data Factory has a setup where it goes out and pulls data from a config database and SQL Server, stores all of this information in variables or parameters within Data Factory, and then when we go to call an actual notebook from Data Factory, you specify those particular parameters in there, and it dynamically passes them in. So this is what gives us the ability to have so few notebooks, is that we can do a lot of our work all within a few notebooks, instead of having to build one for every single unique type of thing we need to do. And then the nice, if you're used to Python at all in any way, these are all what they call cells. Each of these little highlighted sections are like separate little code sections that you can run one by one, especially as you're debugging and building stuff out, and actually test it. The idea being, you run it, you kind of see what your results are, and then if it fails, figure out what you got to fix in the Python code just in this one little piece, and then move on from there to do the next step. And then you can add these cool titles as kind of documentation. You can add markup or markdown language within here to do comments. That's supported out of the box. So lots of documentation capabilities built just right into the notebooks, which is great. The other thing I really like about the notebooks too, that I can highlight, is if you've run, like in this case, we have some runs of some Data Factory code or pipelines that actually called out to a Python notebook. So that's kind of how that works. The nice thing is, because of the way the Databricks works, this ran, however many days ago. I think it ran more than a week ago. Yeah, it ran, 10:20 is when this particular run was done. And we can pull up that specific run. Now, of course, I've lost the tab that it loaded it into, but there it is. Okay, so what you get to see then, that's great with Python, if you set it up right in your cells, is it outputs. So in this case, I had it, written the Python code to say print all of these parameters that were passed in into this particular run, and then it just writes them all out here, so I can actually see what was passed in on this specific run. And it also, in this case, you can load the data. In this case, it was pulling a CSV from a specific dynamic file name that was passed in, and then I dump the results out to what they call a data frame that I can actually then view right within here. So it stores all of this stuff out there for easy debugging when you have an issue or you want to see what was actually loaded. As long as you structure your notebooks properly, it'll have all that information available to you each time it runs to actually see how it all ran, which is really great. So that's kind of the quick and dirty on Databricks and how we use it. I guess I could highlight that what it runs is clusters in the background. So um, the clusters you spin up, you decide how many workers you need, just one, or in our case, we set a minimum of 4. So every time this cluster fires up, it's going to fire up a driver, and then it's going to fire up 4 workers at the same time. When it first starts up, if it detects the load is high on those 4 workers, it'll spin up a 5th, and so on and so forth until it gets to 8. So it won't spin up any more than 8 because you are charged, of course, for every single VM that's up and running. So you kind of have to keep that under control. But then the other nice thing is it does detect that you can turn on this setting to terminate after so many minutes of inactivity. So when it sees that nothing has been done for the last 30 minutes, it shuts down all of those clusters. Also a negative, because then if you do need to spin them back up, they tend to take about 5 minutes, no matter how many different VMs to actually fire back up. But the cost savings is great on that, just because it can auto shut down. Azure SQL DB, I'm not going to spend a lot of time here because we all use SQL Server all the time, but this is just, in our case, we're using the platform as a service version, which is the fully managed version by Azure, Microsoft, and Azure. You don't have to pay a license for it. It's actually built in, or you can bring your own. So if you have enterprise licensing, that might be a good option for you. It has full compatibility with on-prem, but it also has the latest features that you won't have on-prem, which is nice. So this is kind of where Microsoft does a lot of their testing for the latest versions of SQL Server that you'll find. So great low-cost way to do SQL servers. We use it for our config data, as I pointed out, for all of our Data Factory and Databricks running all our ETL. We have all that config data stored in Azure SQL DBs, and even the lowest, which is what they call an S0 level SQL server, is dollars a month to run, because you get up to 250 gigs of storage on an S0 even. So it's a very cheap option for running SQL Server. And it shows up in the portal just like all of the resources, of course. It does show up a little differently in that you'll notice there are 2 things. This is the actual SQL Server, and then this is the database. So you can spin up an actual, as you would expect, a SQL Server instance, and then have multiple databases within it. So then each of those databases you spin up would show up as separate SQL database resources. But they all point to that same instance. So that's basically the same setup as on-prem. You're spinning up an instance. You manage all the setup within that specific instance. Then you can come into the SQL databases. In our case, we just have the one there, as you can see, standard S0, so the lowest level necessary, just because we're not doing a lot with it. And then from there, you can actually see how that one is performing, set up some of the other replication capabilities, but you can't really, you can try to do query. The query editor is okay. It's probably getting better over time. Yeah, it's something that, if you want to do querying, you're probably going to use SSMS like most of us. Or you can actually go out and download the other tool that Microsoft recommends now, which is this Azure Data Studio. Another free desktop tool you can download and set up that actually does work with on-prem SQL as well. So if you do want to go down the route of using this tool, works very similar to SSMS. The only difference being SSMS has capabilities to connect to the analysis services. This does not. This purely only connects to SQL Server data sources, and I think now they've added Cosmos DB support as well. So it's working with some of those, but it's not working with Azure Analysis Services or Analysis Services on Prem at all, at least currently. All right, now we move on to the big guy. So Snowflake. So this is, as like Databricks, like I mentioned, this is a third-party resource as well, built by the company Snowflake, which you may know recently had an IPO where their stock went through the roof. So they're a very well-known company now that has done very well. I've been in contact with them for over 5 years here locally in the Denver area. For different companies I worked at, and was finally able to get it set up to be used here at BC, and have been super happy with it since then. Biggest thing there in that top point, as you'll notice, it actually, the same Snowflake code runs not only on Azure, but AWS and GCP. They actually started on AWS years ago, and then recently, within the last 2 years, have moved into Azure. And then last year, just this year in 2020, moved into GCP. So they're the only database or resource of any kind that I know of that runs across all 3 clouds. And the great thing about that is you actually can already today, if you spin up Snowflake, you can spin it up in Azure and AWS and have them replicating with each other automatically. So you can have full redundancy across clouds, which is mind-blowing how that's capable. So there's some cool capabilities there as far as being able to take advantage of multiple clouds if you need to. They like to sell it as both a data lake and a data warehouse. We really don't use the data lake capabilities, but because this database technology is built on files, believe it or not, the entire database and how it stores all the information is actually in these teeny tiny little files, these little 4K files basically that are optimized so that it knows exactly how to go and pull what it needs. So it has already file capabilities built into the engine. So they've gone ahead and made it available to everybody to use as a data lake. I don't know what the cost difference is between Gen 2, ADLS Gen 2, and the data lake in Snowflake, but I have a feeling the ADLS Gen 2 is still cheaper for large volumes of data. But just know that that is an option with Snowflake as well, that you can store your flat files in it as well, and then query them as well with SQL. But then it also has full data warehousing, which is what we use it for, to store our star-based schema data tables. It costs a lot less than other solutions, specifically Synapse, or before that, Azure SQL Data Warehouse. For our volume, at least, it was way cheaper and that's the other thing with a lot of these is that if you're really big data, it may not be as much of a difference in cost. But for us, it was a pretty big difference because we're not big data by any means. It has instant scale up and scale down of its compute resources, so you don't have to pause the service or anything. You don't have any downtime. You just go into the UI in Snowflake and say, okay, I want to take it up. They do t-shirt sizing, so it's extra small, small, medium, large, extra large, et cetera, with the compute doubling with each of those step ups in size. So if you wanted to go from a small to a large, you just do it in the UI or do it through a call through, however API call that you may do into your Snowflake instance, and it'll just scale it up instantly. And then you're charged, of course, based on your usage at that higher level by a second level, thankfully now. When it first started a couple of years ago, they were actually charging you by the hour. So if you only use 5 minutes of the medium and then scale down to small, you were still charged a full hour for that medium, which kind of sucked. But they've since gotten it to where they bill down to the second now. So that's not an issue anymore, thankfully. You can do time travel, which is a cool capability. It's built right into their SQL queries. You can just do a select star against a table, and then you specify a specific where clause where you actually tell it to go back in time and show you that record up to like 90 days back, depending on the level of Snowflake that you buy. There's different tiers of Snowflake. at different costs. And so you can go up to like 90 days back on a specific table and look at the data all the way back to when it was. Maybe not even there. If the record, didn't even exist, it was inserted after that. Of course, it would return null. But then you could actually find out when that specific record was actually even inserted by doing time travel as well, which is cool. And the biggest thing for me, because I'm a BI person, not a data warehousing person, is no indexing, believe it or not. Because of those micro partition files, that's the way it optimizes everything in memory and stuff, is that you do not need to index any table. And I've done millions and millions of rows and have noticed no issues so far with querying the data. So it's mind-boggling how well it handles big data with no indexing at all required. So that's the great thing about it. Some of the negatives, though, it is ANSI SQL. It's not T-SQL. So it's an older ANSI SQL standard, which is kind of where SQL Server started, 25, 30 years ago, however long it's been now. And then they're kind of, of course, modifying it to their own needs over time as well. But you'll find that a lot of the newer stuff that's been added to T-SQL, of course, won't be available in ANSI SQL at all. And the other big negative is stored procedures. SQL stored procedures don't yet exist in Snowflake. You have to code you code the stored procedures so that it calls out to JavaScript right now is the way it works. But they are working to add SQL stored procedures to the engine. Just no idea when it's coming. And the other negative is it's only available in a few of the Azure regions. It's not available everywhere. So depending on where you are, it may be more difficult for you because the data has to be, transited across a large swath of land or countries to get to you, which may not be ideal. So definitely check out that link, which will actually take you to a page that shows you what regions they're currently in today. Snowflake has its own UI, as you can imagine. Once you get all set up with your own instance, you'll get like a URL with them that's unique to your specific company, and then you set up the logins and all that kind of stuff, just like you would on a SQL Server instance. And then from there, you just decide how you're going to spin up different databases and different data warehouses. So they call them data warehouses, is really their compute. So that's where whenever you do a query that gets run against your data, that's when you spin up compute. And you'll see, you can tell right here in the UI, I'm using this particular warehouse that is a small, that's what the S stands for. And right now it's not running because otherwise there'd be a green dot right there. But even if I just go and tell it to run this query again, it ran it, instantaneously. And now if I go and refresh that whole page, it doesn't always update the status right away. You'll see that warehouse is back up and running again. So one of those things where it's like the Databricks and stuff like that, where it spins up these warehouses. This is thankfully a lot faster than Databricks, because like I mentioned with Databricks, it takes up to 5 minutes for it to spin up. So far, what I've seen in Snowflake, as long as they're fairly small warehouses, they tend to spin up nearly instantaneously, which is pretty amazing to see. And actually, I guess it didn't change because I ran the same query as I did before with that order by. So if I take the order by off, I think it will detect that is a totally different query. So now it is taking a little bit longer because there it had to actually spin up the warehouse, which you can now see has the little red dot or green dot next to it showing that it fired it up to do that query. But there, it only, even waking up the warehouse and running that query, only took 9 seconds. So it's pretty miraculous how well it does. And this is a super wide table. This is our date table that has, I don't know, like 100 columns almost on it. So it's a pretty wide table. That's why it took a little bit longer to come back with 70-something thousand rows. But and it's a small, and that's what we run everything into small right now in Snowflake, and we're really happy. And we've got total room to grow because you can go from an extra small all the way up to what they call a 4x large now is what you can do, and the performance does, you know, increase with each of those levels of compute. So that's the thing to keep in mind, is you can pay more and it'll get done that much faster is the idea. So very cool setup, but like I said, it is ANSI SQL, so there's some drawbacks there. All right, let's see if we can get through all this here, but next is the Logic Apps and Runbooks. I think I kind of mentioned before, this is kind of like the glue. So as you've kind of, and it's funny because I think there's a similar tool in AWS they actually do call Glue that does exactly what this does. But Logic Apps and Runbooks are just kind of a way of you triggering work to be done on some of these other resources within Azure. And the difference between them is Logic Apps are like a low code, no code, drag and drop type interface that I'll show you in a second, where you can actually build out stuff with pre-built little components that you just have to fill in parameters for. Whereas runbooks allow you a little bit more granular control, where you can actually run full PowerShell and or Python code within a runbook to actually get work done. So, you know, depending on what you need to use to get your work done, you've got those options. Nice thing is both of them can actually be triggered either via schedule, just a regular rolling schedule, certain events happening, like files changing on a server. It can actually look for that, you know, every once in a while and say, okay, file changed, I'm going to run whatever, you know, you put into the Logic app. Or they can be triggered by an HTTP post command, which they actually call a webhook, is what they call it. It's just a unique URL that you call and send a simple post to, and that it picks that up and then runs your code at that time. So take a look at those real quick. Nothing super fantastic about them, like I said, especially the Logic apps. They're pretty easy to set up. I can kind of show you this one that we use. Each of the Logic apps, you know, they go into their own designer that's all in the portal. So it's fairly easy to set up once you get them. This is actually a pretty standard Logic app we use over and over again to process all the different parts of our tabular models in Azure AES, which I actually got this code from someone online, just doing a search for processing analysis services in Azure or with Logic apps, something like that, and it's out there freely available to pick up. But I've since modified it quite a bit to work for our setup. But the nice thing is you set up these new Logic apps, you by default get this HTTP request task added to it, and as soon as you save the Logic app, it pre-populates this post URL, the HTTP post URL that you want to use with a unique URL, and that's what you then go and use to, if you want to trigger it via a web post command. But then from there, you're just, in this case, I'm doing a bunch of variable setup, and then it does the actual work of, in this case, it's set up to actually be able to do a scale up of our Azure Analysis Services instance if we wanted, while it's doing the processing, to actually go up to like an S2 or S3 level temporarily. It does that, and then it sits and waits. Once it goes to do that, then it will actually send the post command to actually go and process the tables, which we pass in as parameters in this case. So it actually has a unique list through parameters of the tables down here that we need to process within that specific Logic app. So we've broken up because we've got one big tabular model, we've broken up the processing based on how our ETL runs. We don't run it all at once. We run pieces of it throughout the day. And so then we only process the table pieces that were impacted by those changes. So makes the processing go so much faster. So it doesn't have to wait on everything. So then it just sits and waits for that to finish. If it's successful, it sends out a nice email saying it's successful and scales it back down if necessary to a lower level so it doesn't get charged as much. And then we'll send an email on failure. In this case, it doesn't send an email on success, only because it runs like 4 times a day. So but that's kind of how Logic Apps work. And then runbooks, as you would expect, are a little bit more complex. They're not nearly as nice in the UI because it's just code. So in this case, it's PowerShell. This is actually PowerShell we got online as well. For our dev and test Azure Analysis Services instance, it actually goes out and detects based on a schedule whether to pause our dev and test Azure Analysis Services instance so we don't get charged for them. Because Azure Analysis Services and Power BI Premium are our two highest cost items in Azure right now. So being able to pause those on evenings and weekends in dev and test is super important to us to save the nuts of money. And how those work. Almost done. We got this one and then Power BI, I think, and then we're there. But so Azure Analysis Services we talked about. This is the platform as a service version for online analytical processing, or OLAP, but it's tabular models only. So if you use the SQL Server Analysis Services on Prem, you know that you can use multidimensional and tabular now. Unfortunately, the version that's hosted in Azure is currently tabular only. Will probably stay that way from what I've heard. If you haven't heard, multidimensional's kind of been, I'm not saying deprecated, but not getting a lot of new love basically from Microsoft. So that's kind of why tabular is here. Uses all the same stuff. Tabular, actually, the version in Azure is the newest version, latest version of stuff that's not even in the 2019 version of Analysis Services at this point, even though it just came out. They're constantly updating it. Uses DAX as the main query language. And then this is highlighting what is kind of becoming their new norm as of 2021 when it comes to tabular technology. They're going to actually make Power BI Premium be the place where that's the only place that all of the features of the tabular engine will be available. Next level will be Azure Analysis Services, and then below that will be the on-prem SQL Server Analysis Services for tabular. So right now these are switched. 2 and 1 are actually in the reverse order as of now. But the idea being, once they get the Power BI Premium version of the tabular model up to being on par with Azure Analysis Services, which is they're very close to. They've got like 3 features they need to get into it. It will then become the place where all new development and new features are added, and then a determination is made: should it be added to Azure, or should it be added to the on-prem? So that's kind of just a heads up to what's coming in Analysis Services. Not a lot to demo in Analysis Services because it's just stuff that you're probably all familiar with. What I will show, I thought I had, oh, there it is. I just went right past it. The tabular model, tabular editor is a third-party, community-driven free tool that's great for editing a tabular model directly on the server or locally in a .bim file. Tabular models store their data in a .bim file format. So that's the cool tool for doing that. Quick changes are great within that. That's what I would recommend there. But then, as always, the heavy lifting typically we do still with SSDT inside of Visual Studio. Actually, I don't even need to say SSDT anymore, because with Visual Studio 2019, all of the BI tools are actually fully baked in as separate extensions within Visual Studio 2019. So yeah, you can do tabular model building and editing in this as well, which is where we do a lot of our main work, just because it's integrated fully with source control and everything that we use for our BI tools. All right, so then the last guy is Power BI Premium. So most of you probably are aware that it's a reporting tool. The premium version is kind of the top of the line, has all of the latest, greatest bells and whistles available to Power BI. But yeah, it's the way to get everything that's available for Power BI today. I highlighted paginated reports here, but that is actually changing next year. As soon as Power BI Premium Gen 2 is released, coming up next year, paginated reports will actually be available in the free tier and the pro tier as well, which is great news because I think it should be available everywhere. It was just took them some time to figure out how to do it, and it involved actually upgrading the entire infrastructure for Power BI to make it work. But you also get unlimited sharing, large data sets support up to 400 gigabytes or terabytes. I can't remember. It's some ridiculous number. If you talk to Microsoft, you can pay as much as you want and get really big models put into this setup. And then there's multi-geo support. So if you need some kind of failover capability in Power BI, you kind of have to go to premium for that. As I highlighted, next year, the Analysis Services engine, which is built into Power BI as well. For those of you who don't know, when you're building all those reports in Power BI on the back end, it's building a tabular model as well in the report. So that same technology has been driving Power BI since the beginning, and that's why everything's kind of migrating into Power BI Premium as the source of all that, and then going down from there to the other levels of Azure support. So to demo Power BI, hopefully you've all already kind of seen what it looks like from a UI perspective. It's just a web-based tool that you can actually go out and build reports, make them kind of nice looking for your users. You build them currently today, you build most of them in the Power BI desktop, which is a free desktop application in Windows. And then from there, you can deploy them up to the service and have people browse them from there and interact with the reports. It's got all the interactivity built in with cross highlighting and cross filtering and all that kind of stuff, which is really cool that it's all kind of built in. And it does mobile out of the box as well. There's a Power BI mobile app for both Android and iOS that you get right out of the box. You don't have to do anything to your reports if you don't want to, and they work on mobile, which is great. I could spend a lot of time on Power BI, and that's that. So then we move into source control. As I kind of highlighted through some of the demos, DevOps repos are available in Data Factory, and you can use GitHub as well in Data Factory, along with using GitHub and Databricks, along with most other places within Azure. Some of them are lagging behind a little bit more than others, but there are now that Microsoft owns GitHub, you can expect to see GitHub rolled into everything going forward. Then they've got the DevOps pipelines. If you're used to using those, you can actually set those up. That's what we actually use to migrate our Databricks code between environments, is have a pipeline that goes out and pulls the latest from dev when we're ready to do a migration, and then pushes it out to our test and production environments automatically, which is really cool. You can also use Azure Resource Manager, which is actually how we manage our changes in Data Factory. There's some good Microsoft documentation out there on how you should set up your Data Factory for multiple environments. So we actually do have a separate dev, test, prod Data Factory setup, and you have to use the Azure Resource Manager templates that you can export to actually do that migration across those resources, since they are completely separate resources. You end up exporting it from dev, and then you can import it into test and prod. Is how you can get those to move across. Now, I'm sure you could integrate that with DevOps pipelines then too. We just haven't gone to that level yet with our Data Factory code. Power BI files have the same problems they've had for most people as far as source control. If you're doing large imports and your files get too big, like bigger than 4 gigs, your PBIX files, then you'll have to go out and just save them as templates to strip the data out. It won't remove any of your report code. It just removes the data that's imported into the report. So that's the quick way around that. Thankfully for us, since we do mostly the direct connect to our Azure AS tabular model, most of our PBIX files are small enough that we just use source control for the direct PBIX files. But just know that's an option. And then now they also have launched the Power BI deployment pipeline. So feel free to check that out as well as a way to migrate your code within Power BI as well. It's not really a source control, but it is a way of helping you move your reports in Power BI from dev, test to prod in Power BI through different workspaces. And then the alternative. So we've highlighted some of these as we went through the presentation, but we looked at AWS versus Azure because we were doing a lot of stuff in Microsoft. Azure made the most sense for us. We compared Azure SQL Data Warehouse, which is now Synapse Analytics, to just all the different Azure SQL setups, and then Snowflake. And just for compatibility, price, feature set, all that kind of stuff, we preferred Snowflake. So that's kind of going to be a decision you're going to have to make based on your volume of data, your feature set that you're looking for, and capabilities. Then that's kind of the things to keep in mind. We saw when we talked about Data Factory the difference between using the data flows and the Databricks. I didn't get into the actual data flows in Data Factory because we don't use them, but we decided to use Databricks mainly because of compatibility with Snowflake at the time. That did not exist and data flows didn't exist at all in Data Factory, so we really didn't have much of a choice at the time, but it's something we may revisit. And then support for languages. If you do decide to use Databricks, you saw that you could do Python or Scala or R or .NET, which is coming next year. Kind of which one to pick. We chose Python mainly just because even though it's a new language for everyone on the BI team, it's a language that's been out there long enough. There's so much help online. I have yet to find something I haven't been able to figure out by seeing samples of code online in Python. So that's kind of been a great thing for using Python. And I've gotten really comfortable with it in a very short period of time, like within a year and a half. So it doesn't take a lot to learn, but then of course I have a coding background. I actually have a C# background, so picking up languages is not as hard as it might be for others. We talked about the analysis services and Power BI Premium. We will definitely be migrating our model into Power BI Premium next year when that feature becomes fully available, which will be amazing because we pay basically the same price, I think, for these two options alone every month. So we'll be able to basically cut our costs in half when it comes to those two as soon as we can migrate off of Azure Analysis Services, which will be amazing. And then the reporting solution at the end, do you do Power BI, Tableau, Burst, or anything else on the web? Just options that you're going to have to evaluate on your own, but from us, from a cost performance perspective, Power BI by far outweighed all the others. All right, I'm running out of time very quickly. So future stuff, we've kind of covered a lot of these as well, but just to kind of highlight them, we talked about the Power BI Premium becoming where all of the Azure Analysis Services features for tabular will be, the most. So that's definitely happening next year, that we will move our model that we have in Azure AS into our premium instance, which would be great. Since we've been live, have added a lot more support for Snowflake in Azure, which is great. Microsoft has a really great working relationship with Snowflake, and I hope that continues. So now they have made it available to connect directly to Snowflake within those tools. So, eventually we may look at switching over to some of those data flows in Azure Data Factory, because now we can get the direct connection to Snowflake that we need. That's an option on the table. There's the bring your own key, or BYOK functionality out there. We haven't used any of that in Azure or Snowflake, but it's available in both. If you're really looking for better encryption of your data and encryption that you have control over instead of third party, that's an option as well for security. And then you got, of course, machine learning, AI We currently aren't using that with our setup, but we architected it in a way that that is there for us, which is great. That we'll be able to leverage a lot of that here in the future. And then we got the big guy that Microsoft's pushing, Azure Synapse, that's out there now. Whether we go that route or not, we'll kind of keep our eye on it over time. And then there's probably 5 other things down the road that I don't even know about, which is the thing with Azure. So if you don't like change, you may not want to go down this route. You may want to stick to on-prem because the stuff in the cloud changes constantly. But yeah, if you like to learn and you like playing with the new latest greatest, then yeah, going to the cloud is amazing for that. Just a refresher, there's kind of the data warehouse architecture that Microsoft's been putting out there that we've moved towards, which has been a great journey over the last 2 years, and happy we on that route. And then this is their redone version with now Synapse in place, kind of showing how Synapse is going to sit at the top of the stack as a unified experience. The nice thing is you saw how I switched between Data Factory, Databricks, Power BI, all those different tabs and browsers and stuff. That's where Studio comes in. They're trying to build a single tool that you just use the left nav to switch between those different layers of your BI solution. So kind of clever. We'll see how it works. I'm keeping my eye on it. So yeah, here's just a quick summary of what we went through. We did the what's, the whys, and the hows with our solution. I guess the future is the wins, or win is now, because it's all already running in production for our particular scenario. But yeah, we went through the whole stack of everything that we've set up in as great a detail as I could in this time frame. So yeah, fill out your session evaluations. There's my contact info, so feel free to reach out to me on Twitter, just at Steve Wake, just my name, and then steve@wakebi.com if you want to email me is the email address. But with that, we will move into live video Q&A. So I will see you in a